Hello, dear of course. The today's chapter is one topic C programming fundamentals. So, in this topic, we are learning the syntax of the C programming and the concept like tokens, identifiers, variables, etc. etc. Okay, so we will move to the next topic. So, the topic is variable. Understanding variable. So first of all, variable is the name of the memory location which stores some data. So it means I have some memory location. I given the name to this memory location. Okay. So which stores some data. It means it stores some data like age is 25. So think first of all a container in a computer RAM, each variable has specific types and unique name and identifiers. So it means this is the RAM. Okay, this is the RAM. In this RAM, so many memories are there like this. So each and every memory is a container. Is a container. Okay. In this container, I'm storing some value and I given a name like age. So this is the beauty of this. And each container and each variable has the specific type. Which type of the data it is? Int. So age is int is equal to 25. Int age is equal to 25. Is it right? The same way. And the unique name we can call it as a identifier. So first of all, syntax of the variable we have to learn. Syntax of the variable. First we have to declare the data type. Next, the variable name equal value semicolon. This is the syntax of the variable. So one example, so that is the data type is int and the variable name is age and the value that I am storing in this container, that is the age container, that is 25. So it means when I declared int age means one memory was created. I named to this memory location, that is age. So here I have to store some values. That is integer type of the variable. So I given a name int age is equal to 25. So it means the memory is understanding, the compiler was understanding the int age contains the value that is 25. Okay, we will move to the next topic, that is naming conversion. So before giving name to the every memory location, there is a rules to give this name. Yeah, there is some rules. We have to give the name like this only or that only, like that we have some rules. Okay, so first of all, the first rule is case sensitive. It means always there is a difference between small h and the capital A H. Okay, it means these variable names are case sensitive as treated as two different variables. This is also a different variable and this is also a different variable. And the second topic, that is first character must be an alphabet or underscore. it cannot start with a digit. It means variable always start with alphabets H or capital A also we can use, or we can start with the underscore H or underscore name, anything we can use, but it does not start from number H. This is the wrong format that we are using. Okay, the third concept is no spaces. Blank spaces are common or not allowed within a variable name. So it means when we are declaring the variable name, we never going to give the spaces. Don't give the spaces when you are declaring variables. For example, I have a variable name that is full name. So we have to write our full name like this, full capital N name like this, or full name without any space we can write like this. Okay, but don't write a full name with space, so it will never going to treat it as variable. So the compiler will always going to give the error like variable declaration wrong, like that the compiler will give the error. So this is not a format to declare the variables. Never going to declare space here, space here. Okay, this is the wrong. And the third concept is, and the fourth concept is, sorry, the fourth concept is special symbols. Special symbols means no symbols other than underscore is permanent or permitted. It means we have to use, when you are declaring the symbol, I mean variables, don't use at h like that, at g like that. We never going to use the symbols here, so we have to use the underscore only when you are declaring variable underscore h, or first name last underscore name like that. Don't use the last at or hash like that symbols in when we are declaring the variables. So the next topic is primary data types. So the next topic is the data types. Data types. So there is so many data types in a C programming language. Mainly we are declaring, we have to understand that is the character, integer, float, and double. And the character also, in an integer also there is a unsigned and signed integer also there, and float also there is a unsigned and in a unsigned and signed floats are there. So mainly we are focusing on the core topics, I mean core data types, that is character, integer, float, and double. Okay, the first character. So when we are declaring the variable, on the time only we have to use the data type. So data type always give the two things. One is the what type of the data we have to store, what type of the data, that is the number, and how much size I have to allocate. Okay, and how much size I have to allocate in this memory location. So if it is an integer type of data type, I have to allocate 4 bytes. In older compiler, we have to allocate, we allocated the 2 bytes. But right now we are using the Visual Studios and the code blocks and IntelliJ, and so many online compilers also have the 4 byte of the memory location it was allocating right now. So that's the reason the size is 4 byte in a memory. Okay, we are always going to access the 4 bytes, the first 4 bytes for to store the number that is 25. Okay, so 25. And the format specifier, the format specifier is the percentage d when we have to access and when we have to display the value to the user on the time. We have to use the format specifier that can understand the what type of the data the memory was have, what type of the data that memory contains, and what type of the data that memory wanted to store. So that's the purpose we have using the format specifier, that is percentage d. So integer have a percentage d format specifier. The character have a only one byte memory. It means only one byte will be allocated. So if it is an integer, the 4 byte will be allocated. If it is a float, again the 4 byte will be allocated. If it is a double, the 8 byte will be allocated. Okay, 1 2 3 4 5 6 7 8 byte will be allocated. So you have to just understand this. The character have only one byte, and the integer have the 4 bytes, and the float have a 4 bytes, and the double have a 8 bytes of the memory location. So for double, the format specifier is the percentage lf. For float, the format specifier is the percentage f. And for int, the format specifier is the percentage d, and the character, the format specifier is the percentage c, because we have to print the character. That's the reason print function should understand which type of the data the print function is accessing, and the scan function also which type of the data that scan function was adding to the memory location. That's the reason we need a format specifiers to store and access the data from the user from the memory. And the next topic is types of constants. So types of constants means there is a three types of the constants. One is the integer constant, another one is the real constant, the third one is the character constants. The first one is the integer constants. It means what type of the data that I can store in my memory location. It means, okay, constant means what type of the data I can store in my memory location. The type is integer and real numbers also, and the character also I can store. Okay, so first of all, the first topic is the integer. The integer contains the whole numbers without decimals. So whole numbers are there, 0, 1, minus 5. These all are the whole numbers. And the hmm, real constants. The real constants stores the numbers with decimal points like 3.14, 2.5, or minus 2.5, also a real numbers. So I can store in this memory location 2.5 or 3.14 pi value. Okay, like that. And I can store the third value, that is the character constants, the single characters in single quotes. And number of characters we can call it as a string, but right now I can only store the single character in memory by using char data type. Char, okay, grade is equal to a grade, semicolon. Like that I can declare the characters. So single character in single quote, but here I have to use the single quote to represent this character as a character only. So then only the system can understand it's a character. Otherwise if I use the double quote, the system can understand it's a string. Okay, if I use triple quote, sometimes the system can understand it's a comments or another type of the info. So that's the reason always when you have to understand the when you have to declare the characters on the time we have to use the single quotes, single quote a, single quote b, and single quote f grade and single quote p grade, like that. Okay, and the next topic is the reserve words, reserve keywords. So reserve keyword means there is some keywords that is already stored into the C programming compiler. Okay, C compilers. Okay, the keywords are reserved words that have a specific meaning to the compiler. So C programming have some brain that can understand some numbers, some values. Okay, that can understand. So, but the compiler will give the meaning to that each and every word and keywords. So there are 32 keywords in the standard C programming. Actually, before that, in English, okay, there is a 26 letters, 26 letters. Okay, in a Hindi, there is a 46. It means 46 letters. In Kannada, there is a 49 aksharas. We can call it as a letters also. Letters. The same way, in a C programming language, there is a 32 keywords. Okay, I hope now you understood. There are 32 keywords in standard C language that cannot be used as a identifier. So the problem is we can't use these 32 keyword as a identifiers. Like we can't use, for example, in identifier means variable. Okay, variable means the name given to the memory location. So we can't use the name as a keywords. Okay, so keywords are the reserved words. We can't use these keywords as a variable name. There is a 32 keyword. The all keywords are here. You can just read it once. In this series I am completing the each and every keywords, each and every keywords. Okay, that is once, only one time I will pronounce these keywords. Okay, one is the auto, another one is the break and case character. You can call it the char, integer, long, and register, and return, and const, and continue, default, do, short, signed, sign off, sorry, size of, static, double, else, enum, extern, struct, switch, type def, union, float, for, go to, if, unsigned, void, volatile, with. Okay, these are the 32 keywords that we are learning in this complete series. Then only you can think you are a, after learning these 32 keywords, then only you can think you are a C programming developer and you have a knowledge on C. Okay, and the next topic is standard programming structure. So this is the very important concept in the C programming. So before learning each and everything, we have to know the structure of the C programming. Okay, structure of the C programming. So how it means, it will show the blueprint how it will looks like. So how the C programming will look like. Okay, that type of data structures we have to learn. So there is a structures, there is a rules, some rules we have to always follow. Okay, that is first, hash include. These are the preprocessor directives we always have to use. I will give the Example also, that is hash include stdio.h. So hash include is the preprocessor directive. It can access or the give the access to the every header files. So right now I'm accessing this header file. So that is the standard input output header file. In this standard input output header file, there is a functions, that is printf functions I'm accessing. Another one is the scanf functions I'm accessing. Okay, I hope you understood. The next line is int main. So int is the return type here, not a data type. It's a return type here. I will explain you later. But it's a main function. So this is the entry point of the program. So we don't know sometimes where the program will be starting, from which point. So this is the entry point from the main function. From the main function, I'm starting my program. In the main function, if I wrote print f double quote students, okay. So in a compiler, in output window compiler, I'm printing students first, okay. The same way the main program will work. The main program is the starting point of the program always. The next line is the printf. So already we accessed the printf from the where the header file, this header file. From this header file we accessed the printf function, okay. Because here there is a header file name, that is the standard input output dot h. Input and output functions will be there. Inputting function is the scanf and the outputting function is the printf, okay. It means I have to show in something. So the printf have some value, that is the next line is the printf function, okay. Printf function, printf, there is a word, that is hello world, semicolon. So always the strings will be represented within the double quotes, so then only the compiler will understand it's a string, like, okay. Printf, the hello word I'm printing. When I'm writing the hello word within this printf function, it will directly going to print the value without any intervention. So it will print the contents that is stored into the printf functions, okay, into the printf. So in a compiler we'll print the values. The values are hello world. It will be printed here. And the next line is the return 0. The return 0 means, so always we need to have a confirmation, that is our program is running successfully or not. The return 0 will be saying to the compiler, or it is returning a message, return 0. It will return some message after each and every lines of code. It's a successful execution. It will give the name, like it's a successful execution, program will be run or executed successfully, like that. It will give the response to the compiler. The next topic is code documentation. In a code documentation, we have to use two types of the code documentation technique. The one technique is the single line comment, the another technique is the multi-line comment, used for short description. So the single line comment will be used only for the short description when you are writing the code. Okay, just think I wrote some code, that is int something, int main, and something something something, and I closed this function or this program here. Before writing the code or after writing the code and each and every line of the code, I have to give some justification. So why I wrote this code and why I wrote this line sometimes. And before writing the code also, I have to give my information, who is writing this code, who is the author. For example, see, in a single line, author is equal to A, B, C. Like that, I can give the name. Okay, for that purpose, I need a single line comments. And the multi-line comments also, they are same purpose I'm using, but sometimes I have to give the large information about the author and the subject name. So in a multi-line comment will be represented by using hash. Okay, I will use the bigger one. Yes, hash star, and it will be ended by again star hash. In the between this hash star and star hash, I can write my multiple line or multi-line contents. Okay, and the single line will be represented by using double forward slashes. And the next topic is the format specifier, the output and the format specifier. So for example, I have to print the, in a print function, printf, it will print so many contents. If I wrote hello in a print function, it will print hello only. Okay, it will print hello only. Hello only in a system, that is hello. So if I want to print, if I want to printf, that is some numbers I have to print, that is int age is equal to 25. I have to print this value, that is the age value. So on the time, one side I have to use the format specifier in a double quote, the another side I have to declare my variable name, that is age, and the another side I have to declare what type of the data that I'm storing. So that data type I have to declare here, the data type, not a data type, that is the format specifier here I have to declare. Okay, the format specifier is the percentage d that I'm declaring here. The semicolon, it is mandatory. The semicolon will always going to say it's a end of this line. Okay, eod, end of the line. So it will represent it like a end of the line, the percentage d comma h. And the next format specifier is the percentage f. Print f, percentage f, and there is a two value I can write. One is the percentage f, that is the format specifier, because when I have to store, when I have to print the real numbers, on the time only I can use the percentage f. And the value that I'm passing here, that is the pi value. So just think, we have a float variable, that is float pi. Pi is equal to 3.14 semicolon. I have to print this number, print this variable number. So on that time only, on the time I can use the format specifier as a percentage f. This is the, it will print the real numbers, and the variable I have to pass here, that is the pi, that is the 3.14 value that I'm printing. So it will print a 3.14. If I declared here, just think, if I declared here as a int data type, so what will going to happen? So in a pi I have a 3.14, but it's an integer, no, it will represent it as a 3 only, not the 3.14. That 3.14 will be removed when I'm printing the format specifier, that is the percentage of, again the 3. Yeah, right now the pi the pi stored the 3 value. The 3 value will be stored into the pi right now. So when I'm passing the format specifier, that is the percentage f, on the time I'm printing not 3.14. So again it was converting into the format specifier, that is the float. So float is always have a point values, so it will print a 3.0, not a 3.14. The value will be neglected here when I'm converting this type of the value into the integer. So we can call it as a type conversion. So but this format is the wrong, so we are always going to use the format, the proper data type, that is float. Then only it will print the 3.14 output. And the last one is the percentage c format specifier. So percentage c format specifier prints the characters. So for example, I have a char data type, char grade is equal to, in a single quote I have to represent, no, so grade is a semicolon. Okay, the grade is a. So I have to print this grade, that is printf open and close bracket. So here I have to mention my format specifier, that is percentage c comma, here I have to mention my value, that is, or I have to pass my value, that is grade semicolon. Now you can think the grade value will be passed to here, and the print function will be print the grade, that is a, in a compiler. And the next topic, reading user input. So here I have to read the user input. So here I learned the output function, here I am learning the input function. So the output function is the printf function, and the input function is the scanf function. Okay, these all are the input and output functions you have to know. Though the scanf function is used to take the input from the user. It means right now by using the output function I print the output to the user, but right here by using scanf I'm accessing the input from the user. Just think, there is a computer. So in this computer I'm accessing some data from the user. So I have to store the value in a age variable. There is a variable, that is the age. So age has the empty memory location, nothing will be stored here. So on that time I have to store some value by using a using the user's input. So here I can type the 25 numbers that will be stored to the age. So this accessed value will be stored to the address of the age. So right now this address of the age, it will store the 25 here into this memory location. So first thing is the scanf function. So scanf function will always going to take the input from the user The format specifier is, for example, I have a int age only I declared. I didn't store any values into this age variable. I just declared. Next, I'm using scan a function percentage d comma the address age. When you are using the scanf, on the time only we have to use the address. So in a printf there is no need to use the address of the variable. So here only we are storing the value to the address of this memory location. So percentage d is means the integer type of the variable I'm accessing. I'm storing that value into the address of the age. Address of the age means the inner part of this memory location. Inner part means that the memory location only. Okay. So I'm storing the 25 number. I'm storing the 25 number into the age. Then only I can print the value, that is printf percentage d comma age. It will give the, again it will print the value, that is 25. I hope you understood the scanf function. The compilation procedure. So there is a procedure to do the compilation. So one is the source code, another one is the C compiler, the last one is the executable code. So the source code means when we are writing some code, when we are writing some code in any text file, so that is the source code. So I given a name it as a hello.c or hello.txt or hello dot something, hello.python, that is the format specifier as the py. And if I want to store the value in a Java programming language, the format specifier or dot notation is the dot Java. Okay, here I'm using the hello.c is the text file. So or I can call it as a source file or source code also. So the compilation procedure, the compiler always access the data from the source code, and it will translate those data it into the .exe file, .exe file. So it means compiler always going to compute or translate the source code to executable or machine executable code. Okay, so the definition is a computer program that translates c code, into machine code, C code into the machine code or binary code. Okay, so first of all I have to convert the source code file to the executable code file. So that's the reason we are always going to use the compilers. So compilers here is the translator. Thank you. I hope you understood the each and every concept. I'm very happy to share the next chapters also. So thank you.